Hello, we're going to be working now on a simple program that will use multiple files and compile and link them all together to create an executable, all from the Linux command line. I'll begin by making a directory to put my project in and then entering that directory. Following which, I'll go ahead and create, using the editor of my choice, a CPP file to store the main part of my program. Lay out the framework of my basic program here. Okay, now my intention is to display a message for the user, so I'll need to include IO stream. No surprises there. And we're going to, in this case, calculate the factorial. If I could spell it. There we go. Let's calculate this factorial of 5, store it in the variable x, and then in our hello message here, we'll go ahead and give out that result to the user, just in case they didn't know what the factorial of 5 is. Now, if you've been paying attention, this is calling a function called factorial that hasn't been defined in this file, or has also been included in any of the libraries included here. My intention then is to create a header file. I'm going to call it mymath.h that will have the factorial function's header prototype defined in it. Okay, using my editor, I'm going to go ahead and create mymath.h, and in there I will follow best practices and define a symbol that will prevent it from being included multiple times. And then include the prototype for factorial. It will return an integer and receive an integer parameter. Alright, now I need to also, from my editor, create the implementation file, the CPP file, that goes along with that. I'll make sure that I include the header file for my math functions. And now all I have to do is define the factorial. We'll do while n is greater than 1, f times equals n minus minus. Turn out that should cover it. Many ways to implement the factorial function. Okay, so at this point I've created 3 files. Let's just look at a directory listing here. We've got main.cpp, mymath.cpp, and mymath.h. I'm going to leave my editor. We'll see those files are out here in the shell as well. Now I need to compile each of the CPP files and then link the resulting object files to obtain my executable. The standard process for this is to do gcc-c and compile the CPP files. You'd need to do those one at a time, like that. At this point, if we do a listing, you'll see that there are 2 .o files that have been created. Those are the object files. They need to be linked together in order to produce the executable program. We'll again use the g++ command, this time specifying the name of the executable that we want to create, and then listing each of the object files that should be linked together along with the standard libraries in order to produce our executable. Okay, let me clear the screen and do a listing for you so you can see that indeed the factorial file was created. That's the actual program, and it's got the execute bits over here. I can run it by saying look in the current directory and run the program called factorial. And you see that our factorial of 5 is 120. Okay, if you're happy, we could stop there and you can run those g++ commands on the command line, realizing that if you have more than 2 files, you need to compile each file and then link all of them together at the end. Now, if you're still interested, I'm going to show you the way to not have to remember that all of the time. Clear the screen here, use my editor again, and I'm going to create a file called Makefile. Notice the spelling on that. It has a capital M on the spelling. As I open up the Makefile, I am first going to tell the Makefile some rules. For example, main.o depends on main.cpp as well as mymath.h. Now, when we want to create main.o, we just have to run g++-c main.cpp. You'll notice that's the same command we used on the command line. Alright, so a little bit of a recap here. This is a target in the Makefile. This says something that we want to create, and then after the colon is a list of files that it depends on. Now obviously it depends on main.cpp, but it also depends on mymath.h because of the include. This means that if main.cpp or mymath.h changes, then the make utility or compilation utility will know that main.o also needs to be updated. So this command down here indicates the mechanism or command to run to do the update. And if you're new to Makefiles, which most of you should be, you'll notice that this is a tab character. It's not spaces, it's a tab, and it must be a tab in order for make to work correctly. Okay, we also had mymath.o, which depends on mymath.cpp and mymath.h, and is compiled with a similar command to compile the object file. Now, if both of those object files are created, then it's okay for us to do the linking. And if we want to create the factorial program, it depends on main.o and mymath.o being built correctly, following which we can do the linking command like so. So in this Makefile now we have 3 different targets: main.o, mymath.o, and factorial.o, each of which have dependencies. You'll notice that factorial it is known to be dependent upon the 2 object files, which means that it's also dependent upon everything they depend on, and so it will get rebuilt if any one of the source files gets changed. Now, one little rule about the way Makefiles work, and that is that the very first target in the Makefile is the main target, and so I want to put factorial at the top to make sure that my program gets rebuilt. Okay, so let me show you this in action now that we have a format of our Makefile. I'm going to save it. I'm going to get rid of the factorial file and all of the O files and my Emacs backup files. Okay, so now we have a very lean directory with just the Makefile and the sources. If I just type the make command, then make will look in the Makefile, and notice the name of the Makefile again is important. It will run the commands in order to build factorial, but in order to build factorial it needs mymath.o and main.o, so it first builds those, then does the linking. After I'm all done, you'll see that the .o files and the factorial files are all constructed and the factorial program runs correctly. Okay, that's basic Makefiles with multiple source files. Remember that in your Makefile, that on the right hand side of the colons, you need to include all of the files that a particular target depends on. If main.cpp included other header files, then they would also be included over here in the space separated list. IOStream is not over here because IOStream is part of the standard libraries, and that's not something that we'll be changing, so we don't have to check on it. Alright, thanks, happy coding, and write some cool code.